So moving to the worksheet number 12, first question. A ball is dropped from the top of a tower and another ball is thrown horizontally at the same time. I hope you got the concept. One ball they simply released from the top of a tower whose initial velocity is u, and another ball is thrown horizontally from the same time. At the same time, then first ball reaches the ground earlier, second ball reaches the ground earlier, both reaches the ground simultaneously, and we cannot decide. Children, for this the answer must be both reaches the ground simultaneously. Let me clear you how. Okay, so two conditions are given. In the first case, the ball was simply dropped from the top of a tower. Ball is dropped from the top of a tower. It may take some time t. Whereas in the second case, the ball was released horizontally. Okay, so in this case, if you consider the time taken, formula for time taken to reach the ground is nothing but root over 2h by g, root over 2h by g. In the first case, if you consider the height of the tower be h, second case also from the same tower another ball is thrown horizontally at the same time from the top of a tower. Okay, so this is also height h. The time taken to reach the ground in this case is time of descent is equals to root over 2h by g. Here also if you consider the time taken to reach the ground, it is also equals to root over 2h by g, because both cases height is same, both cases acceleration due to gravity acting is also same. As the body does not, the time taken does not depend on the velocity of throw. That means it does not depend upon the initial velocity, as it is independent of the initial, it only depends on the h and g. In both cases, h is constant, g is also constant, hence both balls reaches the ground at the same time. Is that point clear, children? Well, moving to the next question. Second question. If a body is projected horizontally from the top of a tower, as a previous case, the time taken by it to reach the ground depends on what factors does it depends on? The time taken to reach the ground always is formula is given by root over 2h by g. So it depends on height of the tower as well as the acceleration due to gravity. Let us see what has been given. Does it depend on velocity of projection? No. Does it depend on height of the tower? Yes. Both velocity of projection and height of the tower? No, because velocity does not depend. Neither of the two? No. It depends on the height of the tower, definitely. Hence, the correct option is option number 2, height of the tower. Okay. Moving to the next question. Question number 3. From the top of a tower, if two stones whose masses are in the ratio 1:2. What is given, children? Masses are in the ratio 1:2. Are thrown one straight up with an initial speed u and the second straight down with the same speed u. So let us see how it is being thrown. Well, the top of a tower, okay, from here, the top of a tower, two stones whose masses are given like this, thrown one straight up with initial speed u, and another stone thrown straight down with same speed u. Thrown, this is also not freely falling, this was also thrown with same speed u. Then neglecting a resistance. What happens? The heavier stone hits the ground with a higher speed. The lighter stone hits the ground with a higher speed. Both the stones will have the same speed when it hits the ground. The speed cannot be determined with the given data. Children, if you would like to find out the speed after reaching the ground, the speed with which this object reaches is, in this case, v is equals to u plus gt. Okay, whatever be the case. And the second case, the body has to travel up and again has to come back down. Okay, If you observe this velocity after going down, this velocity to become v equals to u plus at in the vertical motion. Vy is equals to uy plus ay into t, or in this direction vy is equals to uy is their initial velocity u plus gt condition. Okay, but if you observe this case, this velocity after reaching maximum height, final velocity becomes 0. Again, while coming down, it regains back the same initial velocity. Whenever it falls with the same initial velocity downwards, then again v is equals to u plus at condition. If you take means this vy is equals to, in this case, this is again u plus gt. So here also u plus gt and here also u plus gt. Hence we can conclude that both the stones will have the same speed when they hit the ground. Here speed is u plus gt, here also speed equals to u plus gt. So the option must be third option. Both the stones will have the same speed when they hit the ground. Okay children, well, moving to the next question. Question number 4. Path of the bomb released from an aeroplane moving with uniform velocity at certain height as observed by the pilot is what? Is it a straight line, a parabola, a circle, or none of this? Children, suppose if you go by an aeroplane, a pilot is there, and what is that? A bomb is being released. This bomb moves with some initial velocity u. Because bomb is simply released. Bomb is released from an aeroplane means bomb is inside the aeroplane. So whatever the speed of the aeroplane is, the same speed the bomb will also takes. So whenever this bomb is being released, okay, the bomb as well as the flight is having the same horizontal speed. Okay, as both the bomb and aeroplane is having the same horizontal speed, so whenever the position of the ball is being observed by the pilot, from to the pilot, it appears as if the bomb is falling straight ahead downwards. Okay, because the initial horizontal velocity of both the bomb as well as pilot is same. So for the pilot, the bomb only he could able to see the vertical projection of the bomb. Hence, it appears as if it is falling as a straight line to the pilot. Initially, they both are in the same frame of reference, and the only visibility is that this path. Hence, it appears to be falling in a straight line for the pilot. Okay, moving to the next question. Question number 5. From the top of a tower, two bodies A and B are projected horizontally with velocities v1 and v2 at the same time. And what is given, children? v1 is greater than v2. The given condition is first body velocity is greater when compared to the second body velocity. Which will reach the ground earlier? Well, which will reach the ground earlier means you are asked to find the time. So time to reach the ground depends only on one and only one formula, that is 2h by g. As the two bodies are released from the same tower, so h is constant, and at a given place acceleration due to gravity is also constant. So for both cases, as it is independent of the initial velocity of the throw, whether it is v1, v2 or anything, it only depends on the height of the tower and acceleration due to gravity. Time taken by the two bodies to reach the ground will be same. Hence, we can conclude that both reaches at the same time. Okay, well, next question, question number 6. Assertion. When a body is dropped or thrown horizontally from the same height, from certain height, one body is dropped, simply released, freely falling. The other is thrown horizontally with some initial velocity u from the same height. It would reach the ground at the same time. Yes, that's true. The given statement is true. Okay, so now the reason for this, what they have given is the horizontal velocity has no effect in the vertical direction. Yes, that is also true. Horizontal velocity has no effect in the vertical direction because they both are separate. Okay, so if you consider the time taken, t is equals to root over 2h by g. So during the vertical direction, during the vertical motion, the horizontal, where there is no effect of horizontal velocity because t is only equals to root over 2h by g. So there is no discussion regarding the velocity of throw. So assertion is true. And the reason for that is also true because the horizontal velocity has no effect during the vertical motion. Hence, both the statements are true. Assertion is true and reason is the correct explanation for the given assertion. Hence, first option is true. Assertion is and reason both are true and the reason is the correct explanation for the assertion. Okay, well, moving to the next question. Question number 7. A body is projected horizontally from the top of a tower of height is given 19.6 meter, height 19.6, reaches the ground and you're asked to find the time taken to reach the ground. Children, we have discussed that the time to reach the ground is given as root over 2h by g, which is equals to 2 into h here is 19.6 upon the value of g is given as 9.8. So if you simplify this, 9.8 goes 2 times. Hence, the value of t is found to be root over 2 into 2 is 4. Hence, the time taken to reach the ground will be 2 seconds. Option number 2 must be true. Okay. Well, the next question. Question number 8. An aeroplane is flying horizontally with a velocity u. It drops a packet. Earlier it was a bomb and now it is dropping a packet from a height h. The time taken by the packet to reach the ground will be, so what is the time taken, children? T is equals to root over 2h by g. Okay, formula. So height, instead of height, h is given, gravity is always g. It is independent of the velocity of projection. Hence, the first option, root over 2h by g must be true. Well, moving to the next question. The next last question, that is 9th question, statement problem. Statement A is given and statement B is also given. You have to identify the correct answer from the following. Statement A, for a body projected horizontally from the top of a tower, the velocity on reaching the ground depends both on velocity of projection and height of the tower. So, is that true, children? For a body projected horizontally from the top of a tower, the velocity on reaching the ground depends both on velocity of projection as well as height of the tower. Yes, children, is it true or not? We know that the velocity on reaching the ground is equals to root over u plus gt. This is what we have calculated. Okay, so velocity at any point is given as root over u plus gt. T in this case, to reach the ground is time of descent. So v is equals to u plus g into the time of descent can also be given as root over 2h by g. So what is given means, for a body projected horizontal from the top of a tower, the velocity on reaching the ground depends both on velocity of projection, this is the velocity of projection, and also the height of the tower. So the first statement is true. Statement B, horizontal velocity has no effect in the vertical direction. Suppose a body is falling simply downwards. So in this downward motion, the horizontal velocity has no effect. Okay, horizontal velocity. So this is the second case that which we have already discussed in the previous question. So that is different statement and here it is different statement. But we know that the first statement is true and even we have discussed the same statement number of times in the previous cases. There is no effect of the horizontal velocity during the entire vertical motion. So statement A is also true and statement B is also true. Both the statements are true. Hence, your correct option must be both the statements A and B are true. So first option is true. So children, with this let us conclude the worksheet number 12. Okay, so just go through the concept once again and let us meet in the worksheet number 12A. Okay children, so keep practicing. Thank you.